This is video 2 for the Robotics Engineering Unit. For this one, we're going to start off with manipulators. This is how a robot will interact with its environment. So the first type we have here is a plow. It is the simplest type of manipulator, and it just simply takes whatever objects you have and just pushes them around. The second type is the scoop. This one, it's a pretty simple design, but basically it just, it's just designed to lift something up, just to pick it up. The next type is a friction grabber. This type of manipulator is a little more involved. We have an applied force that pushes on the ball, so that then creates normal forces against the ball. So if I were to take a look at this from a different perspective, so let's say, looking at it edge on, we would have our normal forces we would have gravity trying to pull this ball down, and then we would have friction, which prevents it from falling down. And the greater the normal force, the stronger the friction is. One thing you have to be careful with these, they need to have some elastic give. Or else these parts will break. So you have to be careful with a friction grabber. You have to make sure that there's plenty of elasticity to it. This next type is called a top jaw grabber. It's just like a scoop, except you have an articulating top jaw, which helps to cage whatever object you have in. Kind of like the top jaw, we have the roller claw. And just like with the friction grabber, you need to have some sort of elastic give with this one. Moving on, we now have our accumulators. Once the robot has picked up an object, how do we hold it? What do we do with it? So one type of accumulator we have is called a magazine. And this simply just holds the object. There's many different types, but basically it just holds it. And you can play with the geometry. To hold more objects. So imagine if this were something that's zagged up. It could have the same height, but we can hold a significantly larger number of objects in it. Another type is a conveyor belt. When it comes to conveyor belts, we have two types, indexing and non-indexing. In an indexing, it only runs when you're trying to grab objects. So this right here is an example of an indexing conveyor belt. What's kind of nice about this is that it'll keep the objects evenly spaced. A non-indexing is something that runs continuously. So you would have some sort of stopper at the top, like this, and then as the ball comes up, they would start to gather at the top. But it runs continuously. So indexing, it indexes, so it keeps space between the objects. Non-indexing, it just runs continuously. Another type is a hopper. There are many different ways of designing a hopper, but it's basically just, you can think of the bed of a dump truck as being a hopper. We have several successful characteristics of an accumulator, things that really help it work well. First off is a wide intake. You want it to have a wide mouth to be able to get a lot of different objects. Second is some way of preventing jamming. Some sort of mechanism that helps it so that it doesn't jam and stop working. The third one is a high speed. It needs to be move fast. In fact, it needs to move twice as fast as your fastest speed. You need to be able to gather multiple objects at once. You do not want it to slow down as it gathers. And then finally, you want to be able to pick up objects of different sizes. So with that, you want to have one accumulator that can do more than one thing. Now, we mentioned conveyor belts briefly, so I wanted to go a little further in depth with that. Conveyance, that's basically your conveyor belt configuration. So this is going to play a role in how the system behaves. So the first type is a single belt system. So in this one, we have a flat wall. We have a single belt. And with this one belt design, since the balls are rolling along a plate, they will only move half the speed of your belt. So if the belt is moving at 5 meters per second, the balls will only move at 2.5 meters per second. One problem with this design is if you have objects of different sizes, smaller objects will stop moving. Another design flaw in this is that if the two objects that are rolling hit each other, you will get a jam. Because as this ball is trying to rotate, let's say clockwise, this one will be trying to rotate clockwise as well, and that's going to cause some friction in between the two objects. So a way to get around that then is a two-belt design. So in a two-belt design, it's going to be less likely to jam. All right, that's going to conclude video 2.